Welcome to the lesson on basic constructions. At the end of this lesson, you will be able to construct a bisector of a given angle, a perpendicular bisector of a given line segment, and an angle of 60 degrees at the initial point of a given ray. The construction of an angle bisector, a perpendicular bisector, and an angle of 60 degrees are the three basic constructions that will be covered in this lesson. After constructing these figures, we will verify the results logically. Let's begin with the construction of an angle bisector. An angle bisector is a line that cuts an angle into two equal halves. Here's an angle. Let's name it DEF. ED and EF are two rays. To draw a bisector of this angle, we'll need a ruler and a compass. On the compass, take an arc of a small radius. Taking E as the center, draw an arc on rays ED and EF. The arc intersects ray ED at G and ray EF at H. Now with the same measure, place the compass on point G and draw another arc. This arc will lie within the angle DEF. Repeat this step by placing the compass on point H. The arc that is drawn intersects the previous arc. Name the point of intersection as I. Now, let's draw a ray from point E passing through the point I. This ray, EI, is the bisector of angle DEF. Let's verify this statement. On measuring angle DEF, we find that it is 80 degrees. So the two angles, DEI and FEI, formed by the ray EI, should measure 40 degrees. Let's check this. Yes, each angle is 40 degrees. Hence, ray EI is indeed a bisector of angle DEF. We have successfully drawn and verified the construction. Now let's prove this construction logically. In order to prove our construction, we'll have to prove that angle GEI is equal to angle HEI. To begin with, let's join points G and I and points H and I. Now, two triangles GEI and HEI are obtained. Let's derive some facts about both the triangles. If you recall, points G and H were obtained by drawing a common arc. So EG and EH are along the radii of the same arc. Hence EG is equal to EH. Similarly, GI and HI are equal, as these two are also radii of the same arc. EI is common to both triangles GEI and HEI. By the Sss Rule, triangle GEI is congruent to triangle HEI. When two triangles are congruent, the corresponding parts of the congruent triangles are congruent. Therefore, angle GEI is equal to angle HEI. The ray EI divides the angle DEF into two equal halves. Hence, it is proved that ray EI is a bisector of angle DEF. Next, let's construct a perpendicular bisector of a given line segment. A line segment LM of length 10 cm is given. Let's mark the midpoint of the line segment LM as O. Draw a line passing through the point O. This line is the bisector of the line segment LM. A line bisector is a line that cuts a line segment into two equal halves. Now, let's align this line such that it is at right angles with the line segment LM. The line is now a perpendicular bisector. By definition, a perpendicular bisector is a line that divides a line segment into two equal halves and forms a right angle with it. Now, let's construct a perpendicular bisector using a scale and a compass. Here, another line segment PQ is given. We do not know its length. Taking point P as the center, mark arcs of any radius on both sides of the line segment PQ. Similarly, taking Q as the center, with the same radius, draw arcs on both sides of the line segment PQ. These arcs intersect the two arcs drawn from point P. 2 points are obtained from the intersection of these arcs. Name these points R and S. Draw a line passing through points R and S. This line intersects the line segment PQ at M. Is the line RS perpendicular to the line segment PQ? Let's measure the angle formed at the point M. The measure of the angle is 90 degrees. The line RS is perpendicular to the line segment PQ. It also divides the line segment PQ into two equal halves and also forms a right angle at point M. The line RS is indeed a perpendicular bisector of the line segment PQ. An important point to note is that you cannot draw a perpendicular bisector if the radius of the arc is less than half the length of the line segment. Now, it's time to verify this construction. That is, we will prove that the line RS is perpendicular to the line segment PQ and also bisects it into two equal halves. In order to prove this, we have to prove two conditions: the condition of bisection and the condition of perpendicularity. First, we will prove that the line RS bisects the line segment PQ. As you can see, they intersect each other at point M. Now, let's join the points P, Q, R, and S. Now, let's join PR, PS, and QR, QS. Two triangles RPS and RQS are formed. In these triangles, PR is equal to RQ, and PS is equal to QS. As both are the radii of the same arc, RS is the common side. Therefore, by Sss Rule, the triangles RPS and RQS are congruent. By the CBSE rule, angle PRS is equal to angle QRS. Now, let's consider the other pair of triangles. Triangle RMP and triangle RMQ. Here, side PR is equal to side QR, as these are the radii of the same arc. RM is the common side. As proved above, angle PRM is equal to angle QRM. Therefore, by Sas Congruence Rule, the triangles RMP and RMQ are congruent. By the CBSE principle, side PM is equal to side QM. This proves the condition of bisection. Similarly, by CBSE, angle RMP is equal to angle RMQ. The angles RMP and RMQ also form a linear pair. Since angle RMP is equal to angle RMQ, we can replace angle RMQ in the equation. Since both angles are equal, their measures are 90 degrees. This proves the condition of perpendicularity. Therefore, it is proved that the line RS is a perpendicular bisector of the line segment PQ. We've completed two constructions. Now, let's take up the third. Here, we have to construct an angle of 60 degrees at the initial point of a given ray. A ray PQ is given. We will construct another ray PR originating from point P, such that it makes an angle of 60 degrees at P. Draw a big arc, taking P as a center. The arc intersects the ray PQ at point C. Next, with the same radius and taking C as the center, draw another arc. Name the intersection of the arcs as point D. Now, draw a ray PR passing through D. What is the measure of angle RPQ? Let's measure it using a protractor. The angle constructed measures 60 degrees. Please note, even if we take an arc of any other radius, the angle made between the two rays will always be 60 degrees. From the triangle, you can observe that PC is equal to CD is equal to PD. Thus, triangle PCD is an equilateral triangle. Therefore, the constructed line PR makes an angle of 60 degrees with line PQ.